All right, the plan for this recording is to talk through relations and functions. Relations and functions. So first, let's get some definitions out of the way. A relation, a set of ordered pairs, and that's really, you can stop right there, okay? It's a set of ordered pairs. But let's define a few more things inside of a relation. The set of ordered pairs where the first coordinate is called the domain, and the set of all numbers in the second coordinate is called the range. So what in the world does this look like? Set. So there's set notation. A set of ordered pairs. What's another way of saying ordered pairs? An xy coordinate. A set of ordered pairs. So my ordered pairs, how many ordered pairs do I need? It doesn't matter. I can put as many as I want. Ordered pairs. Can I have a decimal? Sure. Can I have a fraction? Sure. Any set of ordered pairs. Okay? No criteria on what those ordered pairs need to look like. A set of ordered pairs. The set of all first coordinates. So my domain for this set I just wrote, change colors, my domain is the set of all first coordinates. So 2, 3, -1, 0.5, all my first coordinates, 0.5 again, or a half. There is my domain. Range, set of all second coordinates. So my range would be the set of all second coordinates. 3, 5, 5, 5, -1.2. Now, technically, I don't need to write the numbers that repeat more than once. So it's just 3, 5, and 1.2. A relation does not have to have a pattern. A relation is simply a set of ordered pairs. Okay? This could be a relation. The set of ordered pairs, 1, 1, 1, 5, 1, 9, doesn't have to have any special pattern. The x values can repeat. The y values could repeat. I could have 3, 9. I could have 4, 9. The x's can repeat. The y's can repeat. There is no restriction, no limitations on what these ordered pairs need to look like. It is simply a set of ordered pairs. Okay, I made a point of that, made a big deal about that, I should say, because a function is not the same thing. Notice, the first part of the definition looks just like the relations definition. A function is a set of ordered pairs, but it doesn't stop there. A set of ordered pairs for which each input, the first coordinate, is paired with exactly one output, the second coordinate. My first coordinate is the input, the second coordinate is the output. A function, a set of ordered pairs. Now it does have a restriction. There is some criteria of how I can write these x and y coordinates, these first and second coordinates. They don't have to be x and y, but typically they are. So every input has to match up with exactly one output. I'm going to write a setup here, and you tell me if it's a relation or a function. A relation, a function, or both. I'll give you a hint. They're all going to be relations, right? Because a set of ordered pairs is a relation, and I have a set of ordered pairs. So this makes this a little easier. Is it a function? For each input, is there exactly one output? How about for the input of 1? When the input is 1, what is the output? 2. Every time? Yeah, a 1 never repeats. When x is 2, what's the output? 2. When x is 3, what's the output? 2. Each input is paired with exactly one output. That one output happens to be the same number over and over again. That's okay. That's a function. What's this one? That's a 2. Is that a function? Look at each input. Sorry, dropped my eraser. Look at each input. When the input is 1, the output is 2. When the input is 2, the output is 3. Each input is paired with exactly one output. That's a function. Is that a function? No. When x is 1, y is 2. Looks good. When my input is 1, my output is 2. When my input is 1, my output is 3. So when the input is 1, let's do a little set notation. Let's call this the input. Let's call this the output. When the input is 1, my output is either a 2, or it's a 3, or it's a 4. Every input must match up with exactly one output. Not true in this case. The input of 1 has 3 different outputs that it matches up to. In the first few examples, if we did the same little chart, we have 1, 2, 3, 4, 5. The input of 1 goes to 2, 3, 4, 5. I guess I didn't have a 5 on the input, did I? So this input of 1 goes to 2, input of 2 goes to 3, 3 goes to 4. There's exactly one matchup. For every input, there's exactly one output. Well, how about this top one? That's kind of weird. The input is 1, 2, 3, 4. The output is 2. Does the output from 1 go to one number? Yep. Does the output from 2 go to one number? Yep. From 3? From 4? Yep. They all go to a single number. Unlike over here, this third example, my 1 goes to 3 different outputs. If you have more than one arrow coming off of your input, it is not a function. Another way of saying it, if your first coordinate shows up more than once, not going to be a function, provided the y value is different, of course. Okay, a function. For every input, there is exactly one output. What does that look like on a graph? What if I were to graph our parabola that we've graphed in the past? Is the graph of a quadratic, is a parabola a function? For every input. Okay, remember the first coordinate is my input, and my first coordinate on an xy axis is the x coordinate. So let's rephrase this definition of a function to deal with an xy axis. Instead of for every input, I'm going to say for every x, there's only one y. For every input, the x coordinate, there's only one output, the y coordinate. So what does that look like on my graph? Let's pick the x coordinate of a -5. Is there only one y value that goes with it? Yep. How about -2? Yep. How about 1? Yep. For every x, there is only one y value. Notice what kind of lines I'm drawing. I'm drawing vertical lines. The vertical line test says that if you draw a vertical line anywhere on your graph, and it passes through your graph more than once, it is not a function. It's still a relation. It's not a function. Vertical line test. If I draw a vertical line anywhere on my graph, and it passes through passes through the graph more than once, it is not a function. Okay, let's draw one, and you decide whether it's a function or not. Function, not a function. Function. No matter where I draw my vertical line, it passes through my graph only once. All right, let's try another one. How about our basic circle? Function, not a function. That one's pretty easy. I can draw a vertical line a lot of places, and it hits more than once. That is not a function. It hit my graph in this spot, and it hit my graph in that spot. It is not a function. Let's do one more. Function, not a function. Not a function. Even though I can draw vertical lines out here, and they only pass through my graph once. Vertical line test says if I draw a vertical line anywhere on my graph, and it passes through my graph more than once, the graph is not the graph of a function. This graph does not represent a function, because if I drew my vertical line here, it passes through the graph 3 times. Okay? Okay, that is the difference between a relation and a function.